Hi everybody, today I want to talk to you about TPM, or Total Productive Maintenance. Some of you may have seen the movie Ford versus Ferrari. If you're a car nut, you probably have already seen it, and it was a pretty exciting thing to watch. For those of you that haven't, Henry Ford II very much wanted to win a race at Le Mans. Ferrari had dominated it, and no US manufacturer had ever designed and built a car that won the race in its history. As things turned out, there was about a year's worth of time to develop a vehicle that would be a world beater. And ultimately, they ended up taking first, second, and third in the race. Unprecedented win. Three-car team crossing the finish line in unison. And there's all sorts of great backstories about some of the intrigue behind that, and I won't get into it here. What I do want to talk about, though, is one of the drivers' names was Ken Miles. And he was pivotal, he was absolutely instrumental in enabling Ford to pull a credible program together in less than a year. As a driver, Ken Miles was also a consummate engineer. And he could come back to the pits after test driving the car and provide very detailed information about how the car was performing in terms that the mechanics and designers could understand, and therefore dramatically shortening the development cycle. So that relationship between the operator of the vehicle and those maintaining the vehicles is what I want to talk about as being the heart of this thing called TPM, or Total Productive Maintenance. What we're trying to do is get into a situation where those people that operate the equipment day to day are much more involved in the maintenance of the equipment and informing the maintenance department of what needs to be done and what they're observing during day-to-day operations. So how does it work? Well, actually, what's the problem we're trying to solve, right? We want to start with that. We always try to start with the gap between what should be happening and what's actually happening. Well, at this point, if you're listening to this, you've probably embarked on some level of lean management system implementation. So you might have a work cell in place that is running to takt time, which we know is the holy grail of lean, to try and create steady flow of products coming off the end of the line and eliminate anything that gets in the way of that steady flow and causes interruptions in that. So as part of that, you develop standard work for the people that are making the product to use as a consistent way to do their work and also act as a basis for continuous improvement. Probably have done some setup reduction work, so you can go from product A to product B and back to product A again in a takt time or less. You've probably implemented some form of mistake proofing. You absolutely have implemented some forms of visual management so we can tell what should be happening, what's actually happening. Well, really, TPM is the application of all those same principles in the arena of keeping the equipment running as it should. So how does TPM work? Let's go through some of the basic steps, and I'm going to try to keep this as simple as we possibly can. The focus here is not to throw a lot of jargon at you, but rather to understand the basic concepts. It generally starts with a phase that we call clean to inspect. Very simple thing. What we do is we get both the people that operate the equipment and the people that maintain the equipment, and hopefully the leadership from both of those groups to team up and thoroughly clean the equipment. And I mean deep clean, and look for leaks and look for loose covers and look for areas that aren't quite what they should be. All these sort of niggling little problems that occur over time that often get overlooked, or people don't feel it's really warranted writing a repair ticket and calling in scarce resources to do it. Well, we catch up on that stuff. We actually physically tie red tags to them, record them, and then very aggressively fix them. What I don't want to undersell is the social aspect of what's going on with people coming together and talking about the state of the equipment, what's working and what's not working, and deeply understanding some of the idiosyncrasies of it. So this is the beginning of the human side of TPM as well. So now we're bringing the equipment back up to like new operating condition very aggressively, and we have operators and mechanics actually talking to one another. The next phase is, and it's generally part of this as well, is to make the machinery as visual as we possibly can, not unlike the visual management tools that we use in standard work. So pressure gauges get marked with red and green zones, or pressure gauges get added if there aren't any. Lubrication points get marked with signage. If there's grease fittings, we might color code the grease fittings so that we make sure that the proper grease is getting put into the proper receptacle. If there are air filters inside of a cabinet, we modify the equipment so the air filter's on the outside. And the whole idea of this is to create a situation where the person operating the equipment can do more of that regular maintenance that's required, and therefore stay in closer touch with the equipment and act as the eyes and ears of the maintenance personnel. So if they're starting to see something that's unusual or hearing something that's unusual, they can alert maintenance before it turns into a major problem. So the visual management aspect of it, and having people do this maintenance right during the operation, the term is autonomous maintenance, enables the highly skilled maintenance people to be used more effectively. I should say the highly specialized maintenance people to be used more effectively, because they have 100 eyes and ears out in the operating area watching out for abnormalities. So now we have cleaned the equipment, repaired the equipment, made it visual, and probably put together some regular scheduled activities for this thing called autonomous maintenance. Now we have to get into the regular scheduled maintenance, the heavy maintenance of the equipment. The manuals that come with the equipment, usually the documentation, comes with recommended scheduled maintenance. What we want to do is post this up on a schedule board, part of the visual process performance board that the plant may run off of. There'll be a section for how well are we doing in maintaining the equipment throughout the plant. So we'd have one section of the matrix showing what pieces of equipment are under schedule, and the other axis showing the weeks of the year. And within the intersection points of this particular piece of equipment on this particular week requires 10 hours of maintenance. All right, so now we know a week ahead of time or several weeks ahead of time, as the plant manager is carrying out their reflection meetings, that we're going to lose a very critical piece of equipment for 10 hours week after next. Very often what happens in a traditional facility is we postpone the maintenance because it's too important. There's always some hot order that has to be achieved. So in this case, what we want to do is be more proactive. And basically, we expect everybody to be keeping their eye on that schedule and anticipating it and planning around it. So if I have a close relationship with a client, I may call them ahead of time and say, hey, equipment XYZ is going to be down for 10 hours of maintenance. Are you going to be okay with that disruption, or should we build in advance? Should we schedule some advanced build? That'd be one level of conversation. The person doing the supply chain scheduling, materials coming in, have we taken a look at this, and are we bringing some materials in advance so that we can schedule the operators to work some overtime and build in advance of this? So basically we're planning for it. And that conversation can happen in a leadership team meeting at that visual process performance board. Now we want to turn to the maintenance manager and talk about, are we ready to actually perform that maintenance? Is this a special skill that not all of your mechanics have? Are there particular parts that are going to be required in advance? So now we go into the maintenance department, which we have also reconfigured visually, and we will look at the standard work for all of the scheduled maintenance. Are there special skills required? There's a skills matrix up on the wall that shows who can do this. We can confirm that that person hasn't scheduled vacation for next week. And then we can go to the parts areas, and there should be a pre-assembled kit of parts in some visual format that has been put together in anticipation of doing this service next week. So if it's just small parts, we might put them in a plastic tote bin with a checklist on the top. And we have some standard work in the area where a week or 2 weeks ahead of time we're assembling these parts. So if we're short something, we have time to order it and get it in. Or if they're large, heavy parts, we might put them on shadow boards on carts with wheels and roll them out. So either way, we now have the parts We have pre-scheduled the production. We have made sure that the skilled personnel is planning to be in. We now can carry out the work, and when we actually carry out the work, there is standard work that is just as visual as the standard work for production, and we can see it being checked off. And if we're 5 hours into it, we should see that we've done about 5 hours of that 10-hour job and manage it that way. So when the maintenance manager is doing their Gemba walks, they can look to see where scheduled maintenance is taking place and making sure that it's happening the way it should. So essentially, I think you can see that this is simply an extension of the lean management system that deals with a particular aspect of running the business, which is maintaining the equipment. Nothing really all that different about it. These are basic lean concepts that have evolved and been developed specifically for keeping the equipment in a condition where it's running like new all the time, and we're minimizing the disruptions. Again, why are we doing that? Because maintaining takt time, maintaining a steady flow of product so that our customers get what they want when they need it is absolutely central to the idea of lean. And improving safety, quality, delivery, cost requires that the equipment that's being used is using all of the same concepts that we're using with the rest of the standard work in the production environment, as is the continuous improvement aspect of it as well. So we have a class coming up, and one of our partners, Yelena, will be teaching it. You'll see some information on the left here coming up. Really hope to see you. It's going to be an e-learning session, and we'll be able to go through these concepts and follow up with you with any specific questions that you have in your specific applications, and it will help you understand how to continue down this journey of becoming a leaner and leaner thinking organization. So hope to see you there. We're going to have some fun with this one. Take care now.